There we go. Okay. Okay, so let's get going on today, though. Today we're going to go over 3.3, which is division. And before we get rock and rolling, I've got to kind of tell you about why we're doing it. The goal now is to get these polynomials, which we went over in the last section, factored completely. If we can factor them completely, we can find the solutions to the polynomials, which your book kind of talked about at the very end of 3.2, right? But today we're going to go over it a little more in depth. And before we do this, we're going to take a little trip back to third grade, second grade, something like that. And we're going to talk about division. Okay. Because mainly we're going to talk about division, like old school division, because I'm going to use the same terminology throughout the lecture. So let's say back in third grade, you were asked to divide 32 divided by 8, okay? Right? And it was written this way. Later on, it was written as a fraction because really that division symbol is just a fraction. You guys see how it's a fraction with a dot on top and bottom? It's the same thing. So later on, we wrote it as 32 over 8. But in the end, we would have to divide it. So we would say 8. How many times can 8 go into 32? Right? You guys remember this. But I need to make some labels here. This 32 is called the dividend. And this is called the divisor. Okay? So what's on bottom is the divisor, and what you're actually dividing into is called the dividend. It kind of makes sense you're dividing into it. And back then we said, well, how many times is 8 going to 32? We know this is 4. 8 times 4 is 32. We subtracted and we wound up with 0. This is called the quotient. And this is called our remainder, right? Now, so here's what we found. It turns out that 32, of course, divided by 8 is 4. We know this. But because the remainder is 0, it meant that 8 and 4 were factors. So 32 divided by 8 is 4. But what's more important for us moving forward is if you multiply the 8 across, you find out that 8 and 4 are factors of 32. Okay? 32 actually equals 8 times 4. And so therefore the remainder tells us that. If you get a remainder of 0, it tells us that the divisor and the quotient are both factors of the dividend. Okay? So let's do one that doesn't work. Let's say we had 147. Actually, let's do 149 divided by 3. Okay? So same thing. I'm going to work this the same way. Remember, this is our dividend, and this is our divisor. So we're going to say 3, 149. 3 doesn't go into 1. It goes into 14, 4 times? So we put that there, multiply it, 12. 2, bring down the 9. This goes in what? 9 times? 27. And we wind up with 2. Now, there's nothing else to bring down, so therefore this is our remainder, right? Remainder, we've got a remainder here. We've got a remainder of 2. So what that tells us is that really 49 and 3 are not factors of 149, okay? And so the old school way, like when you first learned it in third grade, you would say this is equal to 49 R2, right? But then later on, what we learned was that 149 divided by 3, and this is what we're going to use in this class, is that this actually equals your quotient plus your remainder over your divisor, okay? It was written as like 49 2/3, but it's really 49 plus 2/3. So we're going to use this in this section when it comes to writing division of polynomials, which is what we're about to do, division of polynomials. We're going to write it this way. So you've got your quotient plus your remainder over your divisor, okay? If we deal with the remainder. But really, we don't want to deal with remainders. Remainders mean that these two numbers, and for us it'll be these two polynomials, are not factors. We're trying to find factors. That's the goal over the next few sections, actually. Yeah, the big time goal over the next few sections. Because factors mean solutions, Okay, if we've got a factor, we have a solution. Okay, so let's look at two polynomials that divide nicely. I had x squared plus 10x plus 21, and I want to divide it by x plus 3. Okay, your book goes over two separate ways to do this. There's a long division way and a synthetic division. I'm only going to go over synthetic division because our goal for dividing is to find zeros, and synthetic division is really just a way to test zeros. So I'm going to kind of show you how to do it. Actually, I am going to show you how to do this doing synthetic division, not long division. Okay, for synthetic division to work, if you want to divide these, the first thing, it has to be set up correctly. And to set it up correctly, you remember this is your dividend. It has to be written in descending order, which this one already is, x squared, x, and 21. And if we had missing terms, we would have to include them with zeros. And I'll do that as an example coming up. But so we have to be in descending order, which we are, and with missing terms. This one doesn't have missing terms, so it's not a big deal. Same thing with the divisor. Now, the only thing with the divisor with synthetic division is it's always x plus or minus a number, okay? It's never 2x, 3x, 4x. It's always x by itself plus or minus a number, okay? So let's set up this synthetic division. We'll get this down. It'll take about 2 or 3 attempts, and you'll have it done. It's not that hard. Okay, so here's the thing. Or really what synthetic division was developed for was testing to see if a number was a solution to a function. Okay, that's, and we'll get to that here in a minute. Don't worry about it. But first, we have to think of x plus 3 as a factor. If x plus 3 was a factor, let's say we had some function. I'm going to kind of go off on a little tangent here on the right. Let's say this is not straight line at all. Let's say we had some function that was factored into x plus 3 and x minus 2. And I asked you to solve for the zeros, okay? So we'll get back to synthetic here in a minute. But if I had a function and I asked you to solve for the zeros, and I gave you 2 of these factors, remember you set the whole thing equal to 0, right? You set each one of them equal to 0. And then you solve for them. So x plus 3, the 0 that comes from this x plus 3 factor is actually negative 3, right? That's one solution. X minus 2, you add the 2, right? And you wind up with x equals a positive 2. So now I need you to see this connection because we're going to use it over here. So if x plus 3 is the factor, the solution would be negative 3, right? So when we set up synthetic division, you actually put the potential 0, the potential solution over here. So if it's x plus 3 as the divisor, the potential solution actually is negative 3, okay? So you take this number and you put the opposite right there. So x plus 3, we're going to put minus 3. And then you're going to write descendingly the coefficients from the dividend. So this first coefficient's 1, right? 1x squared. The second coefficient's 10. And the third coefficient's 21. So we have to set it up correctly before we could even work on it, okay? Okay, so then I'm going to just go through this. If you've done this before, that's great. If not, just I'll slow down. The first thing you've got to do, no matter what, once you have it set up, this very first number right here, you're going to bring down below the line, okay? Bring down below the line. And then once a number gets below the line, you multiply it by the potential solution, okay? So 1 times negative 3, that's negative 3, okay? And you put it right there. So negative 3 times 1 goes right there. And then you add vertically, okay? 10 plus a negative 3, that's a positive 7, okay? And then once it's under the line, again, you multiply it by the potential 0. So 7 times negative 3, that's negative 21. You add vertically, and you wind up with 0. I'm going to box that in because that is my remainder. It tells us a lot, okay? Again, we wind up with a remainder of 0. So what that tells me is that x plus 3 is a factor of this dividend, okay? And that's a big deal. X plus 3 is a factor of the dividend. And what we have to the left of the remainder are the coefficients of the solution, okay? The coefficients of actually the quotient. So it always goes remainder, constant, x, x squared, x cubed. It would keep going to the left if it did, okay? So it turns out that x squared plus 10x plus 21 divided by x plus 3 equals, now this is going to be 1x plus 7. Of course, we don't have to write the 1. I just want to show you where it's coming from. 1x plus 7. So this is always the constant. This is the coefficient for x's. If it kept going to the left, we'd have x squared, x cubed, and so on. So it's kind of neat, right? So we found that this is actually our quotient. I'll make this a little smooth, make that part of the box, okay? So this is our quotient, x plus 7. So x squared plus 10x plus 21 divided by x plus 3 equals x plus 7. No remainder, which is great. So just like before with that 32, how we found out 32 equaled 8 times 4, it turns out I can multiply this to the other side, and I know that x squared plus 10x plus 21 equals x plus 7 times x plus 3. I've got it in factor form, right? Pretty neat. Now, we're not doing anything else for right now. We're just, this is our answer for right now, okay? But I need us to be thinking of it in this way. We're trying to get this polynomial factor. That's going to be the long-term goal. But for now, we're just going to focus on how to do this synthetic division. It gets us to that point, especially with bigger numbers. Okay. So let's do another one. Let's do one with a remainder. Okay. Okay. Let's say we've got says divide. Yeah, divide x cubed plus 4x squared minus 5x plus 5 by x minus 3. Okay, x cubed plus 4x squared minus 5x plus 5 by x minus 3. Okay, so I'm going to set this up. And again, remember, if it's x minus 3, if that's our divisor, the potential 0, though, is a positive 3. So we're going to put that there, okay? It's a positive 3. It's going to be the opposite of what's going on up here. And then we're going to write descendingly. Now, look, we've got an x cubed, x squared, x, and constant. So we're going to write those descendingly. So 1x cubed, you'll never have variables right here, guys, okay? 1x cubed, 4x squared, minus 5x, and a positive 5. And then we're just going to do the same thing we did before. Remember, the very first thing is you're going to bring down the first number. So number 1. And then multiply it once it's under the line by 3. 3 times 1 is 3. Add it vertically, you get a 7. Multiply it times 3, you get 21. Add vertically, you get 16. 16 times 3 is 48. Oh, it's positive. 16 times 3 is 48. 48 plus 5 is 53, right? But that's our remainder. So what that tells us is that, look, x minus 3, not a factor of this polynomial, right? We got a remainder of 53. This means that this guy is not a factor over here, not a big deal. For us, though, we just need to find out what the quotient is then, right? So here's how you would write this. Now, look, that's our remainder, constant x squared, okay? So this actually equals 1x squared plus 7x plus 16 plus, remember, it's remainder over divisor. Remainder over divisor. Remainder over divisor. Can you get that? Yeah. Remainder over the divisor. Okay, so this is how we write this. Now, for purposes going on and solving, this doesn't help us out at all because we've got a remainder, okay? So, but to answer the question in this section, we're done. Okay? Questions? Make sense? Yeah, it's not bad. This isn't a bad section overall. And really, it's going to be connecting it to the higher concept later on. Okay. Okay. Let's look at another one. I'll kind of set this one up for you, and then I'll let you kind of solve it out. So let's say we had 5x cubed plus 6x plus 8, and we want to divide it by x plus 2. Okay. Now here's what I was talking about. Look, this is in descending order, but notice we have a missing squared term. So if we have a missing squared term, you have to have a missing term. You had to put the squared term in there. So this, you need to think of this as 5x cubed plus 0x squared plus 6x plus 8. To do synthetic division, you had to have a 0 there, okay? Divided by x plus 2. So I want you to try this one. Try it by yourself. See if you can do the synthetic division on your own. Make sure to put the 0 there when you're putting it in to the bracket. Okay, I'm going to set it up. So I know if it's x plus 2, it's going to be a minus 2 out there, right? We got to change the sign. And we got 5, 0, 6, and 8. I got to bring down the 5. Negative 10. Add it. We get a negative 10. Multiply, we get a 20. Add it, we get 26. 26 times 2 is what? 52? Is that right? Yeah, negative 52. And this would be what? Negative 44? Yeah. Again, no good for us for if we're getting into the solving process because we've got a remainder, but we have to write it like we're supposed to write solution. So this would be, now look, remainder, constant x squared. So 5x squared minus 10x plus 26. Now you can either write it as minus 44 over x plus 2 or plus negative 44 over x plus 2. Either way is fine. If you want to write it as minus and then just put 44 up here, that's okay. Okay, but either one of them is fine. I'll tell you though, this isn't good though. We need remainders of 0 to do the fun stuff that we're going to get to. Okay. Questions? Not bad. It's not bad. It's really just a process. This is one of those things where it's like, just do it. Let's do one more because I haven't talked about one. Actually, let's pull some up from the homework because I know they throw some kind of goofy ones in there. We look over at the homework. I'm looking on page 374. Let's look at. Let's look at 24. I want you to try this one, 24. 24 says x to the 5th plus 4x to the 4th minus 3x squared plus 2x plus 3. And they want you to divide it by x minus 3. Try that one. Okay, if we can do this one, we're set. Actually, no, I'm going to put one more on there too. So you do that, start that one. I'm going to put another one down here. Okay. So and that's kind of backwards, but I'm gonna do number 4 next. So try that one, and then we'll get to number 4. X cubed minus 2x squared minus 5x plus 6. Hey, we're dividing by the same thing. X minus 3. Okay, try those two. And then we'll connect the concept with actually what's going on. Okay, keep working. I'm going to, let's just start it. So 3, both of them are going to be 3, right? Gotta be careful. There's no cube term. So if you want to do this one correctly, look, we've got a x to the 5th term, x to the 4th term, but then there's no q term, so you have to have a 0, an x squared term, an x term, and a constant. Okay, so we have to include that 0. There's really a plus 0x cubed here, plus, and then it goes back, right? Bring down the 1. Oh, that's gonna take a while. 3, 7, 21, 21. Ugh. 63, 60. Oh, Jesus. 180, 182. Get the old calculator out. 182 times 3, 546 plus 3, 549. Definitely not a factor. Okay, so now look here. Oh, yeah, I need to talk about this. Something else to kind of understand or conceptualize is that, look, this is a 5th degree polynomial. We're dividing it by a 1st degree polynomial. And when you do that, if you ever divide by a 1st degree polynomial, what you're doing is you're knocking down the degree. So we've done that already. If you go back, here, I'll show this one. This is a 3rd degree polynomial. divided by a first degree, it leaves you with a second degree. It always just knocks it one down. So I know because it's a fifth divided by 1, this first term is going to be x to the 4th. Okay? And then plus 7x cubed plus 21x squared plus 60x plus 182. And then we've got this remainder of 549 over x minus 3. Okay? And then the second one, same thing. Now we don't have a missing term here, cubed squared x constant. So we're going to put 3 there, and then we got 1 minus 2 minus 5 and a positive 6. So we bring down the 1, 3, 1, because you had vertically, right? 3, negative 2, negative 6. Hey, this one winds up being 0. That means we have a factor. Again, we're cubed, that take away a 1, so it leaves us with a squared, a quadratic. X squared plus x minus 2. But that's good. It means that these two, this x minus 3 is a factor of this polynomial. It also means that x squared plus x minus 2 is a factor of the polynomial. I mean, think about this. If we write this out now, we know x squared minus 2x squared minus 5x plus 6 is equal to x minus 3 times this little quadratic, x squared plus x minus 2. That's what's going to matter coming up, okay? That's what's going to matter. We turn this third degree really into a multiplication of a first degree and a second degree, which is awesome, okay? Now, for this part of the homework, though, there's your solution, okay? Questions? On Zoom, you guys good? Any questions? This was kind of, that one was crazy.
So with that solution, the x squared plus x minus 2, could you put the x squared and the x together, make it x cubed minus 2?
No, you got to multiply to do that. This is addition.
Right, I'm stupid.
That's okay. X squared times x would be x cubed, but that's multiplication. This is addition. So we got to separate. Keep them separated, right? Offspring, I believe. Yeah. Okay. So now let's talk a little bit about what we're leading into. The first thing, your book kind of goes over this remainder theorem and factor theorem. I'm going to go over it. I don't think it's that big of a deal, but it needs to be noted. Okay. Remainder theorem is kind of neat. The remainder theorem says, look, if you have a dividend, let's say f of x, a function is the dividend. Okay, you're declaring a function of dividend, and we divide it by this whole like x minus c thing. It turns out the remainder is f of c. Okay, it's f of c, and that's kind of easier to show you than to kind of talk about. Let's do one that wasn't too crazy. Let's do this one right here. Okay, I'm going to show you on this one. Let's say we declare this a function, f of x equals 5x cubed plus 6x plus 8. Okay, we're declaring that as our function. So f of x is a dividend. Now this is going to be a dividend though. We're going to take this f of x. We're going to divide by this x plus 2 right here, okay? Now, if we wanted to know the remainder, because really we want to know the remainder tells us if x plus 2 is a factor of this function. We can plug in f of, now remember I told you how it was like the potential 0, that's why it's written as a minus c. So we're going to plug in the opposite sign here. And what's going to happen is it's going to pop out our remainder, okay? We'll show that. So let's plug in negative 2. Remember it was x plus 2, you're going to plug in negative 2. So 5 times negative 2 cubed plus 6 times negative 2 plus 8. Okay? This equals negative 2 cubed is 8, or negative 8 actually. So negative 8 times 5, that's negative 40. 6 times negative 2, that's negative 12 plus 8. Negative 40 minus 12 is negative 52 plus 8 gives me negative 44. It gives me my remainder, okay? So if you plug in the potential 0, right? Remember the x plus 2? So it's really x minus c. You change the sign. That's why it's got the minus sign there, okay? You plug that in, it'll give you your remainder. And we knew this was the remainder already because we already divided this out, right? We did this one earlier. We divided it out and we found out that the remainder was negative 4. And this is important because it can really tell us then, without having to do the division, if our function is divisible, if we can divide by that, I don't have that many pages left. If we can divide by that function, or divide by that divisor, okay, divide evenly. So if we look at one, let's find one. Yep, let's say we've got f of x equals 2x cubed minus 3x squared minus 11x plus 6. And I want to divide f of x by x minus 3 to find the remainder. But we don't have to divide anything to find the remainder. We're just going to plug in the positive 3. Remember, if it's x minus 3, that means it would be a positive 3 into the function, okay? A positive 3 into the function. So if I plug the positive 3 in, I get 2 times 3 cubed minus 3 times 3 squared minus 11 times 3 plus 6. 3 cubes 27 times 2, that's 54. 3 squared is 9 times negative 3, that's minus 27. Minus 33 plus 6. 54 minus 27, well, that's 27, right? Negative 33 plus 6, that's a negative 27. This winds up being 0, okay? So this tells me that, hey, this function, 2x cubed minus 3x squared plus minus 11x plus 6, is divisible by x minus 3, and also 3 is a 0. It's a solution to this function. Okay? It's a solution because remember, we're trying to find where f of x equals 0. That was at the end of the last lecture. We're trying to find out where f of x equals 0. Well, we found it. X equals 3. Okay? That's one of them. That's one of the solutions. Okay, so that's the remainder theorem. The factor theorem is actually right here. I'm not worried about that. You can read that if you want, but this is the remainder theorem. It's kind of neat. Okay, so let's get to the fun stuff. What does this lead us to? This leads us to the examples where we're actually finding zeros. Okay, we finally are getting there. I'm going to steal one. This is on page 42. We've got this function, or it's number 42 on page 374. This is number 42. We've got this function, x cubed minus 2x squared minus x plus 2. We're going to talk a little bit about this function before we do what they ask us to do, okay? So x cubed minus 2x squared minus x plus 2. Okay, before we get started on this function, we need to realize a few things. First off, let's talk about the degree. The degree on this thing is 3, okay? So a degree of 3, we know, we talked about this, I think it was last time. The degree is 3. That tells me that we're going to have 3 factors. So this will factor down into 3. It also is going to tell me that we have 3 solutions, okay? So I know I've got 3 solutions. And another thing that we need to talk about actually is because it has 3 solutions, we really need to take out just a single binomial, like a single divisor, like x plus 1. I think they're going to do x plus 1 for us. They're going to give us a hint here. We're going to factor out x plus 1, and when we do that, it leaves us with a quadratic. And I need you to understand, look, we at this point know how to solve quadratics. We went over like section 1.5 the first day of class. We solved quadratics. 2 lectures ago in 3.1, we talked about solving quadratics. as part of like solving x-intercepts, we know how to solve quadratics. If you watched, I'd make this reference every semester. Some people get it if you've seen the show. If you watched New Girl, they played this game in the show where like the floor was lava, and what was the game called? Do you remember what it's called? I forgot what it's called. It doesn't matter too much. But in the end, it's a safety couch, right? We all play this as a little child or maybe as an adult, and you jump from couch to chair, right? And the floor was lava, so therefore the couch was safe. Well, look, the quadratics are our safety couch. If we can get this thing factored down into a quadratic, we can solve it from there. Because we know how to solve quadratic, we can use quadratic formula, right? And boom, we've got the answer. So let me show you in practice how this is going to work. So let's read 42 here. We've got this function. It says use synthetic to division to divide f of x by, so divide f of x by, is it x plus 1? Yeah. And then use the result to find all zeros. Use the results to find all zeros. So this is really the base of how we're going to solve tomorrow, which is going to turn into a bigger, I say tomorrow, the next lecture, is going to turn into a bigger kind of solving. So let's do this first. Let's divide out x plus 1. Well, we know if we're going to divide x plus 1, it's going to be a minus 1 outside. And then look, we've got descending order. We've got the nice, everything's there, right? Cubed squared x. So it's going to be 1, minus 2, minus 1, positive 2. And we're going to divide this away. Okay, so we bring down the 1. Put a negative 1 here, right? Multiply it. Add it. We get a negative 3. Multiply it, we get a positive 3. Add it. We get a positive 2. Multiply it, we get a negative 2. Hey, hey. We get a remainder of 0. But here's what matters for us. What that means now is our function, we factored out an x plus 1. It factors evenly because we have a remainder of 0, right? And it leaves us with this quotient, okay? It leaves us with this quotient, x squared minus 3x plus 2, okay? X squared minus 3x plus 2. Which is nice. Remember, I just talked about that goofy example. This is our safety couch. We can solve this, right? Because remember, we're solving for zeros, and to find all the zeros, we have to set everything equal to 0. Well, I'm going to factor this completely because I think this quadratic will factor to show we have 3 factors. X plus 1. This is the nice factoring because x squared by itself. This minus 2 minus 1. Yeah. Multiplies to give me a positive 2, adds to give me a negative 3. Hey, check this out. 1, 2, 3. We have 3 factors that include an x, that have an x. Our degree is 3, right? That's not a coincidence. And remember, to solve for the zeros, it was the same as solving for x-intercepts. You set each one equal to 0. So negative 1, we knew that one already because we had a remainder of 0. X minus 2 equals 0, x equals 2. X minus 1 equals 0, x equals 1. Hey, degree of 3, 3 factors, 3 zeros, 3 solutions. That's how it is. Okay? Questions. Now, this is what 42 asks for. 42 asks for these 3. I'm going to go one more step to include some stuff from the last lecture. Okay, that last lecture video. And I'm going to do kind of 42 part B. I want to graph this now. Just a rough sketch. Okay, a rough sketch of what's going on. Now look, we know in behavior here. Actually, let's do that. Remember, zeros are just x-intercepts. So on a graph, they're gonna look like x-intercepts. We've got negative 1, we've got a positive 2, we have a positive 1. So we've got 3 x-intercepts. The end behavior here, we've got an odd function with a positive leading coefficient. So what that means, since it's positive leading coefficient, I know this very last right 0 is going to go up and to the right. Because it's odd, it's going to be opposite for the very left 0. Okay? And look, if you've seen that lecture now, you know, look, none of these repeat, right? They don't have any multiplicity other than 1. So therefore, they go through. We even have a y-intercept right here of 2. So it goes up, it does something like this. So that's just a rough sketch, okay? Rough sketch. To tie in what we learned in the last lecture, okay? Questions? You guys have any questions online there other than, hey, I want to see another one of these? This is interesting. Oh my gosh, he makes this so intriguing. Okay. Let's look at it. I want you to try this one now. And I'm going to see if I can find an example. Yeah. So let's say I gave you f of x equals 15x cubed plus 14x squared minus 3x minus 2. So I want you to divide f of x by x plus 1, and then use this to find the zeros. And I'm going to give you a little bit of time because this is going to take a little bit of time. It's just a longer process. So divide f of x by x plus 1. That's really what we're going over today. And then that, look, it's going to pop out a quadratic, right? X cubed. This is just a first degree polynomial. And then you solve the rest, solve that remaining quadratic out. Okay, I'm going to come back here. So let's see. I got to divide the negative 1 out, right? X plus 1 is minus 1. So 15, 14, negative 3, negative 2. Bring down the 15, negative 15. Add, we get a negative 1, positive 1. Negative 2, positive 2, 0. Hey, hey. It's really kind of, this is like spoon feeding us. Okay, the very end of the section, they're just spoon feeding this to you. But what this means is that our function now, we know that x plus 1 is a factor, when really we know x minus 1 is going to be a 0, okay? But it leaves us with 15x squared minus x minus 2 as the other factor, right? Your quotient right here is your other factor, okay? And then let's factor this, if we can. In this section, we'll be able to factor all the quadratics. So 15x squared, I'm going to do the factor by grouping method. So negative 30, this becomes negative 6 times 5. So 15x squared minus 6x, group that together, and then 5x minus 2. Let me move this down. I can take out a 3x here, and I'm left with 5x minus 2. I don't want to change that, so I'm going to take out a 1. 5x minus 2. So it leaves me with 5x minus 2 times 3x plus 1. So 5x minus 2 times 3x plus 1. This is that AC method of factoring. If you want to go back and look at it, it's fine. You can use a quadratic actually at this point to solve it, because really the goal is to get the two zeros, the two other zeros, right? Now we know, look, 3 factors. So therefore x plus 1 equals 0, x equals negative 1, right? 5x minus 2 equals 0. Add the 2, divide the 5. We wind up with 2/5. 3x plus 1 equals 0. Subtract the 1, divide the 3. You wind up with negative 1/3. So these are our 3 solutions, right? Again, 3 solutions, 3 factors. Degree of 3, not a coincidence at all. Okay? Not a coincidence at all. And just because I live a wild and thrilling life, I will graph this on a coordinate plane. Okay? So let's see this. Now, again, nothing repeats. So we've got, we're going to go through the x-axis. Then the y-intercept's negative 2 here. Negative 1. Negative 1/3 is about right there. 2/5 is about right there, right? Now we know, again, we've got the same exact end behavior, 15. So positive, I know this is going to go up. So it really does something steep like this. And then to the left is going to go down because it's opposite. It does something like that. Okay? Something like that. I'm not too worried about this part for now, but I want you to connect the dots here, because really what this means is that x-intercepts are solutions, right? We talked about that in that last lecture, right? X-intercepts on a graph wind up being solutions up here, right? That negative 1 is right there, okay? And it gives me a remainder of 0. All of these things interweave, okay? They all interweave. 2 examples left, and then I'm out of paper. Okay, let's look at another one. And this is, do you have your book on you? Okay, that's fine. I'm going to kind of describe it then. This is number, can you see that up there? Yeah. Okay, like the tables. Okay. That's not too bad. Hold on, watch this. Watch this zoom in action right here. Let's look at number 50 here. So if you don't have your book at the house, I'm probably violating some copyright rule. Actually, I know I'm not, because I'm taking a class in it, because we're doing this for education. But let's look at number 50 here. So tomorrow, when you bring your, when you come to class tomorrow, or when you're watching the lecture, you really need to bring that TI 83 or 84. We're going to utilize it. We're actually going to use it to really solve in the next class period. So you've got to have it on you. We just had to have it. But if you've never used it, that's fine. If you have, you'll realize this is the table feature in that 84, and we're going to use it to actually solve these polynomials. So let's look at 50. We've got this equation here. I'm going to write it down. I know you can't see that because I'm writing it to the side. 2x cubed plus 11x squared minus 7x minus 6 equals 0. And what they did is they put this equation in a calculator, okay? They put the equation in the calculator, and then, oh, I've got the answers right there. I need to block that, right? And it gives us this table, and then we've got to solve it. It says, in exercises 47 through 50, use the graph or the table to determine a solution of each equation. Now, remember, we just talked about this. The solutions are really the x-intercepts on the graph. So if we look at this table, we've got to find the x-intercepts. Remember, the x-intercepts are where y equals 0. So y equals 0 right here. So x equals 1 is going to be a solution, okay? Okay, so now I'm going to come back here. Zoom out. Okay, So x equals 1 I know is a solution from that table because y equals 0. So if x equals 1 is a solution, I'm going to divide it out. And remember, 1 is the solution. It's not that it's the factor. X equals 1 is the actual solution. So it's going to go right there. And I'm going to divide this out. 2, 13, 13, 6, 6, and 0. You can even draw a little happy face. Why not? Okay. If we did not get 0 here, it means we did something wrong because we know from that table that x equals 1 is a solution already. Okay. So if we did not get a 0 for the remainder, we did something wrong, just probably algebraically, as we're working through this. Okay. So now let's see what's left over from this equation. We know, look, if x equals 1 is the solution, x minus 1 is the factor, right? And what's left over is 2x squared plus 13x plus 6 equals 0. Okay? And now, again, we've got to factor this. Ugh. Okay. I'm going to do it over here. 2x squared plus 13x plus 6. This is 12. So 2x squared plus 12x plus 1x plus 6. Factor 2x out, and I'm left with x plus 6. I don't want to factor anything out of here, so it's going to be a 1. That leaves me with x plus 6 times 2x plus 1. Okay, again, this is factored by grouping, or the AC method, or blah, 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 blah. That's called the bridge method as well, if you want to look it up. But in the end, it factors into x plus 6 times 2x plus 1. Okay? And now we can find our other two solutions. Now we knew one of the solutions already. X minus 1 equals 0. X equals 1 is a solution. We knew that. X plus 6 equals 0. X equals negative 6 is a solution. And 2x plus 1 equals 0. Subtract the 1, divide the 2. And x equals negative 1/2 is a solution. We found all three of these. Okay, we found all three solutions. Questions? And stopping there. Okay, for homework, so this is 3.3. Starts on page 374. Look, I'm not doing long division questions. We're only doing synthetic. So we're going to start there. 17 through 49 odd. 17 through 49.